So here we are at strong acid and strong base. Aqueous hydrochloric acid reacts with aqueous potassium hydroxide to form liquid water and aqueous potassium chloride. All right. 1 mole of aqueous sulfuric acid reacts with 2 moles of aqueous sodium hydroxide to form 2 moles of liquid water and 1 mole of aqueous sodium sulfate. Aqueous proton plus aqueous chloride plus aqueous potassium cation plus aqueous hydroxide forms liquid water plus aqueous potassium plus aqueous chloride. 2 moles of aqueous proton plus 1 mole of aqueous sulfate plus 2 moles of aqueous sodium cations plus 2 moles of aqueous hydroxides form 2 moles of liquid water plus 2 moles of aqueous sodium cation plus 1 mole of aqueous sulfate. Oops, there's a little typo there. Sulfate anion. Okay, let's pull this up a little bit. 1 mole of aqueous proton plus 1 mole of aqueous hydroxide forms 1 mole of liquid water. Strong acid and insoluble base. 2 moles of aqueous hydrobromic acid plus 1 mole of solid magnesium oxide forms 2 moles of liquid water plus 1 mole of aqueous magnesium bromide. 2 moles of aqueous protons plus 2 moles of aqueous bromide plus 1 mole of solid magnesium oxide form 2 moles of liquid water plus 1 mole of magnesium cation plus 2 moles of aqueous bromide. Let's pull this up a little bit. 2 moles of aqueous protons plus 1 mole of solid magnesium oxide form 2 moles of liquid water plus 1 mole of aqueous magnesium cation. All right, let me just bring this up. I noticed that in this molecular equation, weak acid and strong base, there's a 2 here. That 2 should not be there. So if you can get rid of that, that would be really helpful. Let's see. And this should not be capitalized, but 1 mole of aqueous hydrofluoric acid plus 1 mole of aqueous lithium hydroxide forms 1 mole, that 2 should be eliminated, of liquid water and 1 mole of aqueous lithium fluoride. Okay. 1 mole of aqueous hydrofluoric acid plus 1 mole of aqueous lithium cation plus 1 mole of aqueous hydroxide forms 1 mole of liquid water plus 1 mole of aqueous lithium cation plus 1 mole of aqueous fluoride. Okay. Aqueous hydrofluoric acid reacts with aqueous hydroxide to form liquid water and aqueous fluoride. 1 mole of aqueous carbonate plus 2 moles of aqueous protons form 1 mole of liquid water and 1 mole of gaseous carbon dioxide. 1 mole of aqueous bicarbonate reacts with 1 mole of aqueous proton to form 1 mole of liquid water and 1 mole of gaseous carbon dioxide. 1 mole of aqueous sulfite reacts with 2 moles of aqueous protons to form 1 mole of liquid water and 1 mole of gaseous sulfur dioxide. 1 mole of aqueous bisulfite reacts with 1 mole of aqueous proton to form 1 mole of liquid water and 1 mole of gaseous sulfur dioxide. 1 mole of aqueous sulfide reacts with 2 moles of aqueous protons to form 1 mole of gaseous hydrogen sulfide. 1 mole of solid calcium carbonate reacts with 2 moles of hydrochloric acid, aqueous hydrochloric acid, to form 1 mole of liquid water and 1 mole of gaseous carbon dioxide and 1 mole of aqueous calcium chloride. 1 mole of solid calcium carbonate reacts with 2 moles of aqueous protons and 2 moles of aqueous chloride to form 1 mole of liquid water and 1 mole of gaseous carbon dioxide and 1 mole of aqueous calcium cation and 2 moles of aqueous chloride. 1 mole of solid 1 mole of solid calcium carbonate reacts with 2 moles of aqueous protons to form 1 mole of liquid water and 1 mole of gaseous carbon dioxide and 1 mole of aqueous calcium cation. So under reduction and oxidation, we have aqueous iron 2 chloride reacts with solid zinc to form aqueous zinc chloride and solid iron. Zn is zinc, Zn2 plus, zinc cation, iron 2 cation, iron plus 2. Reduction half reaction. Iron 2 plus 2 electrons forms iron. Oxidation half reaction. Zinc goes to zinc cation plus 2 electrons. Let's see. I noticed that this equation wasn't balanced. Oops. So in this equation, I noticed it wasn't balanced, and I would feel a lot better if it was balanced. So there needs to be a 2 in front of this water and a 2 in front of the hydrogen, if you can do that. Let's see. So I made them red, so that might make them easier to find. All right, so 2 moles of liquid water decomposes to 2 moles of gaseous hydrogen and 1 mole of gaseous oxygen. Oxidation numbers. 1 mole of gaseous propane reacts with 5 moles of gaseous oxygen to form 3 moles of gaseous carbon dioxide and 4 moles of steam. And that works for this chemical reaction too, which is exactly the same. H is +1 in both the reactant, C3H8, and the product, H2O. H did not participate in redox chemistry. Now we can just call it hydrogen, but H is fine. C must be calculated. Maybe I should put that in there. C, or carbon, must be calculated. For propane, C3H8, the sum of the oxidation numbers must equal 0, and the oxidation number for H is +1. 3x plus 8 times 1 equals 0. 3x equals -8. X equals -3/8. For carbon dioxide, CO2, the sum of the oxidation numbers must equal 0, and the oxidation number of oxygen, this O means oxygen, is -2. X plus 2 times -2 is equal to 0. X minus 4 equals 0. X equals 4. Using the activity series, this reaction will occur. Solid zinc reacts with the copper plus 2 cation. Maybe I should put aqueous here. The aqueous copper 2 cation to form the aqueous zinc cation and solid copper. This reaction will not occur. Zinc cation and copper metal will not form zinc metal and copper 2 cation. Example. Solid aluminum reacts with aqueous copper plus 2 cation to form solid copper and the aqueous aluminum cation. 1 mole of solid aluminum reacts with 3 moles of aqueous copper 2 cation to form 1 mole of solid copper and 2 moles of aqueous aluminum cation. 2 moles of solid aluminum reacts with 3 moles of aqueous copper 2 cation to form 3 moles of solid copper and 2 moles of aqueous aluminum cation. All right, so here I'm just going to call this M1. So M1 equals the product of M2V2 divided by V1. V1 equals the product of M2V2 divided by M1. M2 equals the product of M1V1 divided by V2. M2 equals the product of M1V1 divided by V2. M1 equals 18.00 M. V1 equals, we don't know. M2 equals 0.500 molar. V2 equals 250.00 milliliters. V1 equals M2V2 divided by M1. These two should be subscripts. I'm assuming that that got converted in as you were pasting this, but if they're not, these need to be subscripts. So V1 equals the product of M2V2 divided by M1. V1 equals 0.500 molar times 250 milliliters divided by 18.00 molar equals 6.94 milliliters. Solution chemistry. 1 mole of aqueous hydrochloric acid reacts with 1 mole of aqueous sodium hydroxide to form 1 mole of liquid water and 1 mole of aqueous sodium chloride. M1V1 equals M2V2. molarity times liter, or you could just say M times L. Moles of solute equals molarity times liter. Liters equals moles of solute divided by molarity. And in part 1, I went over what these mean. The capital M is molarity, capital L is liters. Liters equals moles of solute divided by molarity. Molarity equals moles of solute divided by liters. Also, 1,000 milliliters equals 1 liter, or 1 milliliter equals 1 times 10 to the negative 3 liters. Moles equals molarity times liters, 1.05 moles per liter, multiplied by 0.02706 liters equals 0.028413 moles sodium hydroxide. Aqueous acetic acid reacts with aqueous sodium hydroxide to form aqueous sodium acetate in liquid water. 0.028413 moles of sodium hydroxide times 1 mole of acetic acid divided by 1 mole of sodium hydroxide equals 0.028413 moles of acetic acid. So these two formulas of acetic acid should have the subscripts that this chemical formula does. This 2, that 3, that 2, this 2, that 3, that 2 should be subscripts. Here's the formula right here. Okay, molarity equals moles per liter equals 0.028413 moles acetic acid divided by 0.02500 liters equals 1.14 molarity or molar acetic acid. Now down here in the practice problems, I've been thinking about how to name this. I rather would not name these because in some of these, if I give the name, I'll also give the oxidation number. So I would just say CaCl2, CH4, OF2, KMnO4, COCO3, CO2S, CO, CO2. Even though they know the names, NH3, I'd rather just say it like that, and because here if I say copper 1 sulfide, that'll give them the answer. Okay, zinc plus copper 2 forms zinc cation and copper. 2 moles of proton react with iron to form iron 2 cation and hydrogen gas. 1 mole of gaseous methane reacts with 2 moles of gaseous oxygen to form 1 mole of gaseous carbon dioxide and 2 moles of steam. I didn't include, let me go ahead and include the phases here. So, okay, so just to be consistent here in these first two, let me go ahead and say the states. Solid zinc, I have that not in red, solid zinc plus aqueous copper 2 forms aqueous zinc cation and solid copper. And then here 2 moles of aqueous protons react with solid iron to form aqueous iron 2 cation and hydrogen gas.